Thank you, Allison, and good morning, everyone. Very, very excited to have this opportunity to talk to you about something I think is a major challenge in K-12 math classrooms. And that is this idea of retention and how can we help our students remember what we are teaching. So I'm going to jump right into this. You should have the materials, and the chat box is open. I know there's a lot of us in here, but feel free to put some, if you have a question or a comment in the chat box. I may ask for some responses. I will try to monitor that, but it is a really large group, which I'm very, very excited that, and I just think it's so impressive that most of you probably just finished school either this week or last week, and you've decided to jump on and take advantage of a conference where you want to learn something to move forward. That's why we're a profession. We're always trying to improve upon what we are doing. So with that said, I'm going to go ahead and get started. And I know when I was a teacher, I struggled myself with retention. And when I say struggle, I could sense that the kids were not remembering information. So in today's session, we are going to talk about a specially designed activity that is specifically focused on retention. But in order to kind of get to this, we also have to look at the type of practice activities that we are giving students and the structure. And then we'll move into kind of lessons learned from my experiencing working with schools as they began trying to implement this particular technique. So if you want, just throw in the chat box like what your grade level responsibility are. If you're a teacher, if you're a general ed teacher, a special ed teacher, or your administrator, supervisor, I'm assuming that you all are doing something with math in order to be in this session. Right, got lots of kindergarten teachers, lots of grade levels. As I'm kind of watching the chat, something that I think is also important to point out is this technique is appropriate K-12. So a kindergarten teacher can literally be sitting next to an AP Calc teacher and learn this strategy. Obviously, the content and delivery might be a little bit different, but the strategy elements are appropriate across grade levels, as well as across kids and students. All right, this is great. So as we move into this, there are three sets of materials that you should have access to. One is the handout that has the PowerPoint slides in it. The other one is what I call sort of the planning protocols. And then there's an extra IPF document. And if you don't have those, especially the IPF practice guide, I'll show you where to get it. It's free online. All right, so why do students forget? So I need everybody to kind of just reboot from whatever you had been doing in your previous session and think about what you do in your classroom to help kids remember what they have learned. So one of the things that I think we all agree with is there are kids, especially kids with disabilities, that have difficulties on the front end. And what I mean by the front end is the front end of learning. So the initial acquisition. We know that kids with learning disability, dyscalculia, kids that are struggling, they struggle on the front end. And in math, our content's unique. So a lot of kids will struggle on the front end. The stronger ones just kind of figure it out. They get it. But what we're talking about today is the back end. And this is something I really want to drive home is all humans have challenges on the back end. We all forget things. And this is what we are really trying to focus on. So our content is especially susceptible to problems with retention because our content is all interconnected and it builds upon itself. So there are 4 operations in elementary school. There are 4 operations in middle school. There are 4 operations in high school. It is continually building. So when kids either don't learn something they don't acquire it, or it doesn't remain accessible, then that creates challenges later on. So and if you've taught middle school or high school, we all have experienced this, where we're trying to teach a new content and the kids are not remembering some of those bedrock pre-skills that are necessary. So when you think about our content and what we do, I'm going to oversimplify it into 2 words. In is the front end part. That is the acquisition of a skill. We spend 90% of our time on the in part. And this is that tension that we feel with our pacing. Like, we have so much time to teach so much content. That's the in part. The out part are things that we do to take information out. And I would say our primary mechanism for taking information out is the form of an assessment. And that's something that we want to try to remember, that an assessment is not necessarily going to help kids with retention. So we have to do some other exercises that are going to help kids with retention. Now, as you see on the screen here, I've got 3 heads. Folks that work with me a lot think I have this tattooed, but I don't. But this is really kind of this is really going to kind of drive the conversation today. But this is how kids are taking in information. Actually, this is how everybody takes in information. The first part is what's called sensory register. This is how information is absorbed by the kid. So if you think about it in math class, the primary senses that are used to take in information are visual and auditory. So they're hearing and they are seeing. Those are the primary ones. Now, at the younger grade levels, we can also have this idea of kinesthetic if we are using manipulatives. But the primary mechanisms are going to be in the visual and the auditory. And that's how kids take information in that we're giving them. Now, that happens fairly quickly, a couple of seconds, it's absorbed. Now, this is where, as a teacher, what I find really separates the exceptionally effective teachers versus just kind of teachers in math. That information is taken in, however it's presented, it's taken in and it's moved into the working memory. The working memory is kind of like the oven of the kitchen. It's where the cookies are made. This is where kids are grappling with that new information, whether it's a concept, a skill, a vocabulary, a procedure, whatever it is, they're grappling with that. And in that working memory, they're pulling in related ideas. Now, I'm kind of using ideas because it could be personal experiences. Maybe they've done something at home with it, previously learned content, but they're taking it and they're grappling with it. So as they're grappling with it, if you think about that initial learning, as we move from the instruction, we move into kind of a practice phase, and it's heavily guided. And if we think about early on, as the kids are practicing, they're really slow. They're making a lot of errors. They need a whole lot of support from us. That's all leveraging this working memory piece. Well, as they acquire the skill, it becomes, the fancy word to learning is it becomes encoded. And this is really, really important for our session today. It is being encoded in the long-term part of the brain. So we've got different brain areas of the brain that are working as we learn. So once it's learned, now when I say learn, I'm kind of using that loosely. I'm not talking 100%, 90%, 80%. Whatever they've acquired, it becomes encoded in the long-term memory. That's all what I consider the front end. Once it's encoded into our memory, it's learned. What we have to recognize is there are certain things that have to happen to keep that encoded information accessible. So this is the primary focus for our session, is how to keep information accessible. Now, whether they learn 20%, 30%, 40%, 60%, we want to try to help them keep it accessible. So that is the big piece here. Now, what we are learning in this research on retention is there are critical elements that have to be in an activity in order for it to help keep information accessible in long term. And if it's not in the activity, we're not really helping with retention. So that's one of the big takeaways that I want you to recognize here, is that this strategy is specifically forcing the student to go into their long-term memory in an activity. And that is what will help keep that information accessible. So we are not really leveraging or doing anything with this short term. There are other strategies that are doing something with the short term memory to help kids acquire skills. What we are focusing on is, once it's acquired, what are the techniques that we have to implement in order to keep it accessible? Because if it is not accessible, it almost doesn't even matter that they learned it. So that's kind of the idea here, is that a lot of the activities that we do in math class, first off, are kind of focused on the in, and the ones that we think we're doing on the out to help with retention are not really designed in a way that is forcing the kids into their long-term memory. All right, so the decay. So the fancy word for forgetting or not remembering is called learning decay. And this graph that you're looking at, we're all math teachers, so we should be getting kind of excited about this, is called the forgetting curve. And most teachers are not familiar with the forgetting curve. What we tend to focus on is the reflection of that, or the learning curve, the learning, how long it takes kids to learn something or acquire the skill. This is where we are really focusing on, and this creates tension because we know how many days we have, we know how much content we have to cover, so we're really focused on trying to get kids learning. What the forgetting curve is showing us is how quickly kids forget. And what was most striking to me, in as little as 10 days, kids are forgetting almost 80% of what they just demonstrated that they had acquired. And I think this is really an important piece for teachers to recognize. You sense this forgetting curve. It's just we haven't sort of realized how quickly it is happening. Now, content is really important in this conversation, because in math, there's some content that once we learn it, we are constantly using it. So the forgetting curve is not going to be as pronounced. But there's a lot of things in math that we spend a whole unit in, and then we give the kids a test, and they kind of demonstrate they've acquired it at some level. I'm kind of using that loosely right now. And then we move on, and we don't really touch on it again. Now, grade level makes a difference, obviously. At the younger grade levels, we tend to spend a lot more time teaching things because it's brand new. At the upper grade levels, we tend to move very quickly. So this forgetting curve is kind of our nightmare as a teacher. Like, when the kids, we just got done with the PSSA and Keystones, not to kind of bring that up again, but when those kids open the books and get ready to take that test, this is what you want to think about, is that forgetting curve. How much are they going to forget? How much are they going to remember? So this is going to drive our conversation. What we are trying to do with this technique is flatten the forgetting curve. The more we can flatten it, the more students will have accessible to use. So flatten that curve, that is the key here. So, ideally it'd be great if we go straight across there, but we know that's not the case. But even if we can reduce this steepness, that is a ton more information that they have accessible. So we want to try to flatten the curve. So I want to make this really clear. This technique will not help kids learn something. We are talking about the back end. And again, I recognize kids struggle on the front end, but we spend a lot of time on that piece, and not enough on the back end. So this is going to help kids remember information, or keep it accessible. That's the key. So as we are thinking about retention, start thinking about everything that you do in your classroom that you would call retention. Now, here's another thing I want to bring up. The word retention is, in my experience, I know when I was teaching, I wasn't using it, isn't really a word we use in our planning of instruction. We tend to use the word review. And I want to parse that out now as you're thinking about these activities. Review is not necessarily long-term learning. So if you review for a test the next day, then you're not really focused on long-term learning. You're focused on that test. So if you want to throw in the chat now, what are things that you, activities that you do? And I know there's going to be a lot of them because I know that we do these. And we're going to see computer. So I'm seeing some IXL. I'm seeing review problem of the day, number talks, extra math, CRA, spiral practice, freckle, I'm not familiar with freckle, reflex, bridges. So lots of things are happening here. The nice thing about this technique is it can fit in all of those. So you're doing activities. So there's already time allocated. You're doing some of these activities. What I want you to think about is how can those activities maybe be adjusted a little bit to fit this particular technique? Because many of the things that I'm seeing listed are what I would call typical and are not necessarily incorporating the latest science on retention. So I don't want anyone to think anything that they just put in the chat is bad or wrong. What we want to think about is we need to upgrade some of these things, because most of the things that are being thrown in there are pretty much things that have been happening for a long time. So spiraling is one of them. Spiraling has some benefits, but there are some things that we need to think about improving. So now that I got you thinking about your review activities, everything I saw in the chat's good. So what I want you to think about is how can those maybe fit into some of this technique. So this technique is a practice technique. So I want to make it clear that this could be done for homework. Now, I don't recommend that because homework has a lot of other disadvantages, but I've kind of broken what I consider practice activities that I see K-12. Some of these are going to be more grade level specific, but kind of put a checklist or make a mental note of which ones that you do. So based on what was just put in the chat window, most of you are doing many of these. So I broke it into in class. So that's where you're there, so you can provide some assistance if necessary, or out of class where you're not there and you can't really provide assistance. So these are kind of the things I want you to think about. This technique can fit into all of these potential activities. And if there's something you do that's not on here, feel free to throw that in the chat as well. All right, so that's the background. And again, what I want you thinking about at this point is short-term, long-term memory, and that we're focused on the long-term part of the brain. Second, what are the activities that you are doing right now that you are using for review, but I want you to call it retention from this point forward. And what I really want us to start thinking about as educators is identifying a purpose of practice. So anytime that you say, okay, we're going to practice today, and that happens in math class, whether it's in class or out of class, whether it's on paper or it's on a computer, is practice. And what I want teachers to begin to really think about is identifying explicitly the purpose of this practice today is. And there are really 4 primary purposes. The first one is initial acquisition. So this is practice that follows the first time you're teaching something. Its purpose is to help the kids acquire the skill. So they don't know it, you want them to acquire it. So any practice that follows initial instruction, its purpose is acquisition. And I want this to be made explicitly. Second, the second primary purpose of practice is retention. Now, again, I don't really think we use the word retention as much as we use the word like cumulative review. But anytime that you say, okay, I need to give some practice to my kiddos on some skills, concepts that we had previously learned, anything in that genre, its purpose is retention. Then there are two other purposes which are not relevant for today's session, which is fluency and automaticity and generalization. So I want to make this clear. This practice technique today is really not going to help with automaticity. That's not our goal with this. There's other things for automaticity. What I'm focusing on here is the general learning of math content. So what we have learned, and this is the big idea for today, the practice structure that is used for initial acquisition should look very different than what the practice looks like for retention. And this is where I don't really see that in math class. I see practice and it kind of looks the same. So a big takeaway today is your practice for acquisition should look very different than a practice for retention. And that's what we're going to talk about. So in order to get to the strategy, we've got to look at how we're practicing for initial acquisition. So again, if you happen to have some textbooks, some worksheets that you use, you're at school, and you can take those out, get those out and take a look at them. If not, that's fine. So what the research on retention has shown is there are three critical elements in any activity that are designed for retention. And they are timing of that practice. They are the sequence. So that's the structure. That's what I'm talking about. And then is there some free recall in that? In our session, we are focusing on the sequence, or what I call the structure. So as we are moving through this, what I want you to tune into, if you're looking at some of your practice activities or thinking about them, is what is the structure? Like, what is problem one? What is problem two? And what is that? How is that structured? So we are going to get into this idea of the structure of practice in terms of mixing and what is called blocking. And again, I don't know, I may know some of you, there's a lot of people on here, but if I don't know you, one of the things my experience is showing me is that teachers, we haven't, and I'm including myself in this, we did not really get a lot of information on this idea of practice structures for math. We tend to just practice. So we're going to dive into this idea of mixing. So practice structures are how the problems are sequenced on the page. So, and what type of problem they are. So this isn't about the number of problems. This isn't about if it's a computation problem or if it's a word problem, or if it's a problem with manipulatives, or a problem where they draw a picture or they graph or they have to use a calculator. It has nothing to do with that. This has to do with the sequence of the problems. What are the kinds of problems type that are put on the page? So again, it's not about the progression from basic to hard, because that's how most of your textbooks are set up. The first couple problems are basic, then they get a little harder, then they get more challenging, and then they end with word problems. And I can go off on that progression, but that creates all kinds of challenges for our struggling kids, because they get home and they have to do the most complex problems and they have no help. But what I want you to look at, if you have something in front of you, is what's problem one, what's problem two look like in your practice. So if you have, again, if you have your book, or I notice a lot of people had IXL on there, reflex is for basic skills or basic facts. But students have workbooks at the younger grade levels. Like, what is happening from problem 1 to problem 2? That's what I want you to pay attention to, and take a moment, describe it. If you want to throw that in the chat, what it looks like, that's fine. It's kind of hard to do this. If I had you in person, I'd have everybody looking at their sequence. But as you are thinking about that sequence, or looking at it, here is the most common sequence in math textbooks in what teachers are doing, which is called blocked practice. So anytime that you have kids practicing the same type of problem consecutively, that is called blocked. Now, I'm going to take a wild guess here. If you're looking at something, I'm willing to bet Jared's salary that it's blocked. And I see someone put in most assignments are blocked. So a recent analysis of math curriculum showed that 90% of the practice that's embedded in curriculum, in math curriculum programs, is blocked. So I want to highlight this for a second so that everybody understands this. That picture of my blocks, all the red problems would be the same kind of problem. All the orange problems would be the same kind of problem. So think about, you just teach a lesson on order of operations. In your textbook, all of the practice problems, or most of them, are going to be block practice, all of order of operation. So is this bad? Is this good? Nobody's putting in the chat that they're not looking at blocks. So I'll take that for I probably just won Jared's salary. So block practice is very important. And here's where we got to really parse things out. It is critical for the initial acquisition of a skill. So anytime you're teaching something new, block practice should follow that. Now, block practice can be called mass practice if it's all problems on the same page. So I'm going to use some symbols to delineate this. So A, that all those A's, that means it would be a whole page of the same kind of problem. So the kids are doing order of operation, order of operation, order of operation, or whatever it is. Next, you can also have a block practice where it's chunked together. That's kind of what my picture is showing here. So this would be a page that has 4 different kinds of problem types, but they are chunked together. So there would be 4 order of operation problems that the kids do. Then there might be 4 place value problems. Then there might be 4 area problems, or whatever it is. So that is still blocked practices because the kids are doing the same problem consecutively. Now, what we want to understand is this is important. We have to give kids block practice, but we're over blocking. And the reason this is a problem is block practice does not help with retention. So in other words, block practice has a short-term benefit, and that is to help the kids acquire the skill. So once kids have acquired the skill, block practice becomes no longer useful. Now, this is what I'm most worried about, is you only hear block practice is bad. Block practice is critical, especially for our struggling students. They need a lot of block practice to help them acquire the skill. But I want to just kind of flip to your advanced kids. If you ever had a strong kid go, why do I have to practice this 20 times? I got it after 5. They're actually telling you block practice is no longer beneficial. So we're not going to get rid of block practice. But what we want to do is give kids opportunities for other types of practice. Now, Sarah asked a great question. How long do we stay in block practice? Well, that is a $1 million question that no one really knows, because if you've taught, you know that some kids get it right away, some kids don't, and they need more. So there is not really you need this number of practices. So for this strategy, what you kind of want to view here is once kids have begun to acquire the skill at some level of independence. Now, some of the research is showing around 60%. So you're going to have to just make a judgment here. This is definitely a gray area in this research. Once they've acquired the skill at some level, use your judgment, then block practice, you need to move off of block practice and do something else, which we're going to get into here. But that unfortunately is a question that we don't have a firm answer on. I'm not sure there's going to be a firm answer on that. Because even with kids with learning disabilities, they'll get one skill real easy, and then the next concept is tough and it takes them a lot longer. So it just varies. But block practice has to be important. The issue is we're doing too much block practice. So giving choices, again, I think that's a good idea. It doesn't necessarily help with retention. So let's see how maybe you can apply it to this particular technique. All right, so here's examples of block practice, and I'm sure some of you might actually be looking at this. So in this case, it's all order of operation problems here. So we got block practice. Now, don't be fooled into thinking that this problem with grouping symbols is different than this problem. They're the same process. And then over here, please tell me we're not still assigning 38 problems for our kiddos. But again, it's all the same kind of problems. So what we got to recognize is that's block practice. That is only going to give us a short-term benefit. Now, this is what this is the practice that should follow initial teaching. Now, I'm not saying 10 problems or 30 problems. Use your judgment on that. And obviously, word problems are going to be in there. At the younger grade levels, they may still be using manipulatives and 10 frames and so forth. Here's another example, and I really want to point this out. So this is called mixed. So that generally in a math program means it's skills that have already been taught. But we're looking at the structure. And what you see here in this structure is they have organized the problems by type. So here are 4 addition problems. Here are 2 fraction problems. Here are both missing in numbers. There's a sun for happiness. 1 telling of time, and then some subtraction and some multiplication problems. So this is block. Now this is the A, B, B, C, C, D, E, F, F. All right, so that would be that structure. What you got to recognize is that is not going to help long-term retention. That is only going to give us a short-term gain. And then over here, identifying fractions with using blocks, it's all the same problem. This is not going to help retention. Here's another one, algebra. I know there's a lot of grade levels here, so I'm just trying to cut across the grade levels. This one it even says mixed review. Some of us even use these. I was just with a group of teachers yesterday in Eastern PA, and I showed this, and they were like, I use that. So again, this is called a mixed review, but what I really want to point out here is the way it's structured is blocked. So they're going to practice these 3 problems together. Then they're going to practice these problems together, and they're going to practice these problems together. What we all have to recognize is there's nothing bad about this exercise. It's just not going to help with retention. So if you say today is a practice day, a review day, a study day, prep for the PSSA day, a prep for the Keystone day, and your practice looks like this, what you got to recognize is it is not going to help long term. You are going to get a short-term bump that fades very quickly with the forgetting curve. So what block practice ends up giving us is what's called bored brain syndrome. The brain just, after a while, stops thinking during block practice, and it becomes regurgitation. They're not processing, they're not thinking, they're not discriminating, they're not generalizing. They're just going through the motions. So with that said, and again, I recognize, because I work with enough schools, that teachers are like, oh my gosh, this is a disaster because all I'm doing is blocked. I mean, when I was a teacher and I was writing IEPs, I actually wrote in IEPs to chunk the problems together for the students, because chunk practice can be helpful. So this will help with transfer skills. I think when we get to this new technique, it's going to help transfer, it's going to help discrimination, it's going to help a lot of different things. So the essential question that you need to sort of ask yourself is, how much of your program is blocked? And this is obviously something you want to do. So like long-term thinking here, how do you do review activities? How are you activity set for? I know there's a lot of kindergarten and elementary teachers on here. Stations. I want you to really think about stations, because most centers are set up where there's a teacher at a center, and then the other centers are independent centers. And if you look at my worksheet over here that I have the red, the blue, the green boxes on, the red box is station 1. So they go there and they have a game where they're doing a lot of addition problems. They're there for 10 minutes. Then they rotate to the purple station and they're working with fractions. Then they rotate to the green station. Your stations are blocked practice. So again, I'm not criticizing the station activity. What I'm telling you is, if you're using stations to help with retention, it's not. So you want to figure out, is there a way I can adjust the stations or the centers? I actually think it's kind of hard to do this technique in stations and centers, but that's what I want you thinking about. We're not criticizing any activities. What I'm trying to get you to zero in on is the purpose. What is your purpose? And there's a mismatch. We think we're doing something that's helping with retention, but it's not. So before I go into the technique, here's what I want you to remember about block practice. Block practice will result in short-term gains, long-term pain. It's only going to give us a short-term benefit and not a long-term pain. So one of the things, like your homework, so to speak, is go back, look at your program, look at your practice activities, how much of them are blocked. And the general consensus that I see is it's almost all blocked. About the only thing that's not blocked is the PSSA and the Keystone, the SAT, ACT, and the AP tests. Those are not blocked. All right. So now that I got you upset about block practice, no, I'm kidding. Now that I got you thinking about practice, now we're going to move into the other structure. So this other structure is called interleaving. And I taught for several years, special ed, middle school math, high school math, used textbooks, found worksheets. Never, ever did I hear about interleaving until about 10 years ago. And I was blown away. After reading the first couple studies on this, I thought I need to find all of my students that I taught and write them letters of apologies. If you've taught 2 or 3 years and you've never had that thought, then you're not being very reflective, because I blocked everything. I absolutely blocked everything. So what interleaving is when it's the purposeful not blocking. So essentially you set up a practice activity where the kids are not practicing the same type of problem consecutively. So what you're seeing here are my letters notations again. So instead of having A's back to back and B's back to back, or all A's, we want to set up practice. And I see some folks have heard of this and are using it, which I'm so happy to hear, because we got to get this out into the math world, and it's slow going for some reason. But what you want to give kids, and this is kindergarten through 12th grade, AP kids, honors kids, college kids, basic kids, everything, every kind of kid. We want to give kids practice opportunities where they're going to do different problems in a row. So like ABC, 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 or ABCD, ABCD. Now, a couple things I want to point out. This is not 20 different problems on the page. This is carefully thinking about 3 or 4 dissimilar problems and putting them together for somehow. Again, I'm saying somehow. So it could be, you could do this in a game, IXL, as long as you can mix them to where the kids aren't practicing the same. That's what we want to do. Now, you're going to hear some very specific kind of guidelines with this that I've learned across the schools. You really should kind of stick to 3 or 4 problem types. And you want to repeat each problem about 3 or 4 times. You do not want to have like 30 problems in this mixed page, because interleaving takes longer for the kids to do. So if you put too many problems on there, it's going to defeat the purpose, because they're just going to get too cognitively tired. But it is interleaving that promotes retention. So what I want you thinking about is, and I'm going to draw a rudimentary graph here, we want our block practice to occur on the front end. So they don't know anything. Think about 0. They don't know anything. We start teaching them. We want to give them block practice so they begin to acquire the skill. Now, the better or the higher they acquire the skill, the better. But it doesn't have to be 100% before we can think about interleaving practice. So once we get to this point where the kids have acquired it, if we don't give interleave, then we get this forgetting curve. So what we want to do is come in on the back end and provide this interleaving piece, and not to sort of withhold anything, but I'm recommending 2 to 3 times a month we give kids interleaving practice opportunities as a minimum. You can always do a little bit more, but a good place to start if you're not doing this is try to do 2 to 3 times a month. Now, that's a good entry point. You can do more as you move forward, but I think if you were to do this like once every couple of months, it's probably not going to help, or wait to the end of the year. So you want to start doing this week 1. Now, here's the thing. The beginning of the year, you haven't taught a lot of your new content, so almost all of the practice is blocked. Now, if you're reviewing previous year's skills, that practice should be interleaved. Maybe a tiny little bit of block, but the majority of that should be interleaved. Now, I have a question about IXL, and again, I don't want to suggest that I'm endorsing a program, especially one that costs money, but IXL used to be all blocked. It was not mixed. And there were a lot of districts, including some of where my kids were going, where they were saying, we're using this to review. And when I looked at it, it's all blocked. Now, the good thing is IXL and several other programs have added like a quiz feature. So in IXL, that quiz feature came available in, I think, November, December. It is usually in the test making feature or the quiz making feature that allows the teacher to scramble it or mix it. So IXL is now an option for this if you tune into that quiz feature. But again, I'm not endorsing IXL. I think computer practice has some benefits, but it can also have some drawbacks. But if you have a program, look for the test or quiz or exam making feature, that allows you to set up the sequence. That's where you can usually find the IXL piece. All right, so what I want you thinking about is we're going to continue that blocked. That helps the kids acquire the skill. But once a skill is acquired at some level, then it becomes eligible for IPF. Now, the other thing I want to bring up here is your advanced kids need less blocked. Your struggling kids need more blocked before they get to IPF. So your kids that are getting it quick, they need to go into IPF. Stop making them do it 20 times. They need to get into that. Need to do more interleaving practice faster. Our struggling kids, and especially our kids with disabilities, they need more guided block practice before they get to the interleaving practice. So problem one is dissimilar. So I want to bring this up here. So block practice is when it's the same process. Interleaving is when the process to solve a problem is dissimilar. So like that example in order of operations, just because it has a grouping symbol doesn't mean it's a dissimilar process. So when you teach order of operations, you're teaching kids to kind of go through a process. I got to look for exponents. I got to look for regrouping symbols. I got to do multiplication and division. There's a process. So even though they don't have exponents, they're still going through the same process. That's going to be blocked. What we are looking for is dissimilar problem types mixed together. Now, like was mentioned in the chat before, like how much blocked? That's $1 billion question. Nobody knows. And I actually don't really think there is an answer to that. It just depends on the kid and whatever the content is you're trying that day. But the other kind of gray area in this research that really can bog down teachers is what's dissimilar. So I guarantee when you start trying to make an interleaving, or those of you that may have already made an interleaving, you start asking yourself, is this problem dissimilar to this problem? And I guarantee that's going to show up. And then you're going to ask a colleague and they're going to say, no, it's not dissimilar. You ask another colleague, they're going to say, yeah, it's dissimilar. So I guarantee that's going to be an issue. Don't let that paralyze you and not move forward. Make a decision. But here's the rule of thumb. If you're not sure, you're all math experts. You're trained to teach math. If you're not sure, opt to be more different. So either put them on a different IPF activity or put something really different in between, because the danger is if they're too similar, we're going to get a blocking effect. I got some chat window questions there. That's kind of rapid fire here. I need to make my chat window bigger. So how many problems on an interleave? I recommend 9 to 12. 9 to 12 is what I recommend. And I've seen 9 and 12 kindergarten to high school. A lot of teachers say 9, they don't have the stamina. Yeah, kindergarten had no problem with 9 problems. Actually, had no problem with 12. High school is where you got to kind of be a little careful about what kinds of problems you put on there, because you can't put 3 really difficult problems because it's just going to be bogged down. Also, Get More Math, I think, is another option that has interleaving in there as well. And so another question from Jen, like, how do we, where are resources? Well, the downside to this is teachers are going to have to create these. Now, you got some computer software that you can make them, but I'm talking to the administrators and the supervisors in here, principals. If you want your teachers to do IPF, you got to think about a way to give them some planning time where they sit down and start looking at what they're teaching, thinking about what can be grouped together that are dissimilar, and then figuring out how they're going to do it. I'm going to talk about implementation here, but that is a direct, speaking directly to the administrators here. It takes a little bit of time to make these. All right. So, the Common Core Sheets also allows the mixing piece in there as well. So they're out there. We just got to use them. All right. So, okay, back. I think I got most of those questions. Again, if I missed something, I'm sorry. throw it back in there. I'll try to pick it up. So I see someone gave an example here. So again, I've got a fraction problem, a decimal problem, a whole number problem, and a place value. So what you want to ask yourself is, are those dissimilar? So I would, again, by what you're telling me, they look dissimilar, but I have to look at them. But that example that Elena just put in there looks pretty dissimilar to me. Now, what I want you thinking about is 3 or 4, and they repeat 3 or 4 times. So again, we're at this 12 to 9. I think as a middle school and high school teacher, all of my IPFs would be 9 problems with 3 different kinds on there. At the elementary school, you can maybe do 4 because some of them they're not going to be as involved. All right. I like the chats. I can't tell if you're excited, but I think you're excited. I hope you're excited. So here's your memory aiding device right here. I'm big on memory aiding devices. So the block practice, think of those blocks. And then for interleaving, think about shuffling a deck of cards. So what you want to look at is when you give kids practice, is it blocked? Is it interleaving? But what you really want to look at is what's the purpose? And if you're saying, I just taught this, this is going to be part of acquiring the skill, then it's blocked. If you're saying, I've already taught this, the kids acquired it at some level, I want to help them remember it, then it should be interleaving. So here's another great question. Addition with regrouping and addition without regrouping. Are those dissimilar? Are they similar? So first off, this has to be a decision that you have to make. It's not really a right or wrong. Is the act of determining that they have to regroup and then carrying out the regrouping procedure different than not carrying out the regrouping procedure? I'm kind of leaning towards yes, they are dissimilar, but I would probably put a problem in between those two that is really dissimilar. So I would do addition without regrouping, maybe a rounding problem, and then a problem with regrouping. Or I'm sorry, without regrouping. But those are the questions that I'm just forewarning you. Sometimes teachers get paranoid or they get bogged down, like I'm going to do it wrong, so I'm not going to do it. If you're not sure, separate them. There's no danger in the separation. All right, so let's look at some examples here. So again, if you've got a computer software program that allows the mixing, that's great. How you do this doesn't matter, right? So it can be a worksheet. I've seen worksheets. I've seen IXL. I've seen teachers displaying problems on the board, kids with a dry erase board. I've seen it in a station. Now, the station is kind of challenging because you got to make sure they're doing different problems. Oh, okay, good. Jay Miller put the question that is usually asked right away. And her question, or his question, sorry, I'll just summarize, is, are kids going to block it themselves? So in other words, is kid going to get this sheet that we happen to have in front of us? I think that's what you're asking, Jay Miller. And they're going to look at it and go, oh, these are the same. I'm going to do these first. Then I'm going to do these, and then I'm going to do these. In essence, they're blocking it themselves. I was really concerned about this being an issue. And the reality is we didn't see it very much. What we basically saw was the kids did problem 1, then they did problem 2, and they did problem 3. We did not really see the kids chunking it themselves. So if you kind of think about that, I'm not even sure I would chunk myself. When I went chunk a practice, when you get a work, in order to chunk it themselves, this is what would have to happen. The kid would have to not start solving any problems. They would have to look at problem 1, and then they'd have to say, oh, this is a place value problem. Don't do it. This is problem 2. This is a clock problem. And then go through the whole page and then put them together. So we just didn't see it. However, when we did see it, so I don't want you to think we don't see it. You want to look out for this. But I had a teacher that must have spent 8 hours trying to create like this foldable, stapled paper where they could not block it themselves. And it basically, what we've come to learn is she was trying to solve a problem that doesn't really exist. But when we did see it, this is going to be most of you are probably thinking, oh, it's the AP kids, it's the honors kids. Nope. It was the kids with disabilities that had IEPs, because we tend to teach them a test taking skill to do the ones that they know first and then go back to the other ones. So that is who we did see it with. But again, we did not see it as much. So I know somebody would be like, yep, that's my kids. That's my kids. Even in the special ed classrooms, it was rare. So I don't want you getting like trying to create these things that are just too complicated. Keep an eye out for it. If you see it, then kind of think about how you might correct it. So what some teachers do is they'll put the problems on the board. So they only display one at a time, and then all the kids have to do it. And then the teacher shows them the answer. So they cannot block it that way. Some teachers pass it out and they have the kids fold the paper, or they have it on different paper. So a computer program usually can't skip around. So be on the lookout for it. But again, I just want to calm everybody in here. We did not see it a lot, to the point where I think it's even a concern, but be on the lookout for it. All right, so that's an elementary example. There's the 3 different problem types. Now this would repeat 3 times. So I have seen this on a worksheet. I've also seen the teacher just display it on the board and the kids solve it. Either way is fine, because they're not doing the same problem consecutively. Yeah. So Beth is talking about spreading it out across days. I think it should just be all on one day, and we'll talk about that later. I haven't really played around with it across days, but I'm not going to say no to that. Maybe play around with it. Now, high school. These are high school. Oh, by the way, all these examples are made from teachers actually using this. And I should point out, it wasn't the first time they used it. There was an iteration. So a lot of times it's handwritten, it's problems on the board, and then they sort of get into this kind of format. But I would say the majority of high school teachers end up settling into this format. So they've got boxes, they've got their 9 problems, and what you can see here is here's my A, B, C. I'll do this, A, and then I'll put a circle here so we can delineate. And then here's your A, here's your B, here's your C, here's your A, B, and C. And we are not seeing the kids chunk it themselves. So they are making it explicit. We're doing these 3 kinds of problems. Tell the kids, do them in order, but look out for chunking. It may happen. And I see some people like wanting to spread it out. Everywhere I work with, I sort of I present this as a 30-minute block practice, but I think you can play around with it. Here's another example, just so you're kind of seeing the structure here. One teacher, just by accident, when she made her first IPFs, she set it up like this. So it was real organized in columns like this. So there are 3 columns, and all the A problems went down this way, all the B problems went down this way, and all the C problems went down this way. Don't do that. Kids block that, but I don't think they did it on purpose. They just went down. So do it in a mixed order. I kind of recommend ABC, ABC, ABC as you're seeing here in this format, but you can also do ABC, B, C, A, C, A, B if you want to. What teachers tell me is it's harder to make those. It's just easier to do the structure, but you can play around with it. All that you have to make sure is that they're not doing problems back to back. So math maintenance is another way, but the way we do math maintenance is often blocked or it's just spiraled. And you can spiral, but it's blocked, it doesn't work. So this gives us the attentive brain. So what you got to remember is block practice is kind of focused on your brain basically gets bored eventually, where attentive, you're constantly having to keep firing. So kind of what you want to check yourself right now is all my practice blocked? Do I have any IPF? If so, how much, or do I have to add it in? So this is a question you want to kind of ask yourself as you're thinking about your program and the activities. I just want to show you quickly, block practice will give you, or I'm sorry, interleaving practice is going to give you a moderate effect, which is fairly strong. So we want to think about, it's research backed, some very specific data. And I like showing this because this really shows what happens. If you test the kids right after a whole bunch of block practice, they're going to do better than interleaving in the short term. But as you go out in time, you see that the block practice evaporates. It just completely evaporates. It's almost like learning didn't happen. But then when you see the interleaving, it actually is maintaining as you go farther away. So this graph, I think, hits home for teachers. If at the end of the year, Keystone or any test, Keystone PSSA, which kid has a better chance to do better? The block kid who lost everything or the interleaving? Now, I do recommend that you do a word problem. You can put some word problems in there, but don't make it all word problems. So as we're kind of pushing our 10 minutes here, I just want to talk about guidance for implementation. So the very first thing that has to happen, and this is the planning protocol, the very first thing that has to happen is you got to sit down and you got to list out your skills. This is best done in grade level teams or by courses. So the Algebra 1 teachers are sitting there. And I know some of you are in small schools, you only have one teacher, but it's great if you list it out by skills. So what are we teaching in August? What are we teaching in September? Start listing them out and then start thinking about which skills are dissimilar and can be mixed together. IPF, the question by Beth is a good one. IPF teachers tend to make it skill-based, but you want to put a word problem on there. And they can be manipulatives, they can be small presentations or drawing things, but you want to include a word problem, but you don't want to have all word problems. Only 3 word problems max for an IPF. So once you list out the skills and start combining to get together and scheduling when you're going to do it. So I'm a firm believer that this should be scheduled into your routine, that you do this once or twice every other week on a Thursday. And you literally say, I'm going to allocate 30 minutes out of my period once a week to do the retention. It can be sent home for homework. I'm just pointing that out. But there's all kinds of issues with homework. Do they do it? You can't help them. Are they going to practice it wrong? Are they going to get AI chat GPT to answer it? Photo math? I think it should be done in class. It's, in my opinion, this is that important and it's missing. Now, an IPF session at the elementary level, K to 5, it usually is going to take about 15 or 20 minutes. And it's sort of driven by the teacher. So the teacher's saying, here's problem 1, here's problem 2, and kind of is working the pace out. The middle school and high school, it definitely is going to be a 25 to 30 minute session. Now, with that said, sort of here's your planning protocol. This is what you want to start thinking. If you go back to your school here, is monthly planning of these things. So as you're teaching the skills, they start getting combined and showing up in IPF. So at the beginning of the year, you're not going to have a ton of IPFs because you don't have enough skills. But as you start moving through your curriculum, you can add on more skills become eligible. Now, this can be done in WIN. So if I'm interpreting WIN as what I need, it can be done in WIN as long as everybody's in WIN. If WIN is just a certain set of kids, then you're only going to be giving IPF to certain sets. Everybody needs IPFs. Here's our lessons learned. And all the comments that are being put in, I'm having a hard time keeping up with them, but they're all really good. One driving factor for IPF creations is they should really be heavily focused on your eligible content. Here's some considerations. 2 to 3 times a month is the minimum. I have some schools doing it once a week. Some schools, they're on a 6-day cycle, and that 6th day is an advising day, so their period's already shortened. So they just do it every 6th day. Yes, it can be done in small group. It can be done in whole group. If I'm in your room, the only thing I want to look for is that kids are practicing different problems in a row. Another question that arises, well, what if they don't finish it? Well, handle it like you would handle any other assignment. They could do the rest of it at home. They could do the rest of it in like a study hall, or they just don't do it. It's just over. Your practices or activity is over. But here are the tips I really want to zero in into, and I'm going to skip to this last bullet. It should not look like a test. So I should not walk in a room and everybody's at their desk working on something and not talking, no help is provided, and then it's collected. What you want to do is make it a successful learning activity so kids can work together and help each other. You provide help, provide answers. What I really liked, and this is what a lot of the schools, especially the high school, sort of settled into, is once everybody's done the first 3 problems, you display the solutions. And then the kids can look, say, all right, pencils down, let's take a look at this. Then they can look at it and they can check it. And then you're knowing who's needing some assistance. And then do the next 3, display the answers as you go. So at the end, you're not trying to go over all of them. The other thing you can do is you could, if you're concerned, model the first 3 with the kids. Then guide the next 3, and then let the kids do the next 3 after that. So the key with this is don't make it look like a test. It should be a supported practice that kids are kind of being successful. And I will tell you, schools that do it this way, especially showing the answers as they work through it, an added benefit that we got was a lot of student-to-student discourse. So yeah, you can do this whole group. Can you differentiate it? Sure. If you want to give kids different IPFs, you can do that. You'll just have to figure out how you're going to kind of display answers and give feedback. But sure, you can absolutely differentiate it if you want. I don't necessarily suggest that, Sarah, off the bat, just because you got to make, there's too many of them that you have to make. So sort of make some that everybody needs, then start differentiating as you get more comfortable with it. So here's your checklist. And this checklist is in your planning protocol. So as you're kind of sitting down or thinking about making or starting to really think about how you're going to use IPF, this is kind of your guidance. So what you're looking for is that there are opportunities where there's kind of this ABC sequence that you're confident that the problems are dissimilar, and when in doubt, opt for being dissimilar. Think about 9 to 12. I don't want to say that's an absolute rule, but be careful that you don't do too many problems. If you do too many, the kids are going to reject it. Build this in a minimum of 2 to 3 times a month. Minimum. You can do more. So if you're doing 3 a month and there's 3 skills on each IPF, that's 9 skills a month you're getting interleaved. There was a question a while back about, can you go off grade level? Yes, you can. You can go off grade level with these IPFs. This is the one I just want everybody. We are not getting rid of block practice. We are not getting rid of block practice. We still need block practice. It just can't be all of the practice that we're giving kids. I really found some success. Teachers have found some success with this idea of showing answers as they go. But here are your options. These are kind of what I call non-negotiable. So this is what I would look for. down here are kind of things you got to make a call. Are you going to do homework? Are you going to do computer? Are you going to do, are you going to model, show some kids? How are you going to do small group? Kind of, those are all options for you as the professional in the room to decide. So as you're sort of checking yourself, this is kind of what you should be able to answer. Is block different than interleave? Know the difference. Know the purpose. Yes, you can. There is no limits on what you can put in the IPF, Patricia, as long as you are comfortable they are dissimilar. Do you understand the sequence of IPF? Do you understand dissimilar and similar? This will be the bottleneck when you start trying to make these, is you get all hung up on if they're dissimilar, because I see it. Frequency, how often should we do it? And then am I going to do it in class or out of class? So this is sort of check yourself. If you are answering these questions and you're feeling comfortable, that's good. Now, if you want more information, here are some resources. So if you're a member of CC, so that's a lot of our special ed teachers, director of special ed, there is a special issue on practice, and there's an article in it about blocked and interleaving. Volume 15, 2019, I was the editor of a co-editor of special issue. There's a book, which I love, From the Laboratory to the Classroom. It's not free, but what I want to zero you in on here is this website, retrievalpractice.org. If you haven't been on there, get on there. It is awesome. And that picture there is a practice guide, 13 pages. You want to learn more, that's free. Download it. Read it this summer on the deck, poolside, on the beach, so that you start to develop some deeper knowledge of IPF. But when I sort of want to wrap things up here, thank you for putting that in there, because we're about pushed to our time limit here. So the difference between spiral and interleaving, they're very similar, but I don't see spiraling where they've mixed 3 problems together that are repeated 3 times. Most spiraling is just circling back, usually 1 or 2 problems that are splattered throughout the program. That is a form of retention, but it is not interleaving. Now, I'd have to look specifically at the spiral, but I've given you the checklist for you to review your spiral. And if they are not mixing 3 different problems repeated, then it's not spiraling. All right. So just remember, block practice will give you that bored brain syndrome, short-term pain, long-term gain. And the interleaving is what's going to give us that durable learning. Hello, Mrs. Mayberry. Good to see you again. I'll tell Tyler you said hi. And I am not seeing your curriculum or your programs, but my experience and what I'm seeing on a daily basis is telling me that we are not giving block practice the due diligence and importance that is necessary to help our kids retain information long term. So with that said, I think it's right about 10:45. And I'll turn it over to Allison. Thank you, everyone. I appreciate you spending some time in your summer to better your professional knowledge, and I hope you have a wonderful summer.